All right, so in the first part of number 6, we're just looking for a pattern. I set up the Fibonacci sequence here up to 8 terms, and then we took f of 2k minus 1. What they're saying here is put k equal 1 first, so 2 minus 1 is 1. F of 1 is equal to 1. And then when we do the next one, here k is equal to 2. 4 minus 1 is 3. This is f of 3 is equal to 2. I took the sum of this one, put it down here, and now I add f of 3 to that, and I get 3. Now I'm going to do k equal to 3, and that'll be f of 5, and f of 5 is 5. And I took the sum here, added 5, and get 8. And then you can kind of see 4 f of 7, and that's going to be 13. 13 and 8 is 21. And we notice that each of these sums was f of 2 times whatever k was. So in terms of n here, the sum of n terms will be f of 2 times whatever your value is. That's pretty cool. So now all we have to do is prove it. So let's do it. So let's see, this is problem number 'So we start with P of n is such that S of n equals f of 2n. That's what we're trying to prove. For all n is an element of the positive integers. We're good with those. And then we're going to start with step 1 was P1. Okay, so the sum of the first one, the sum of the first Fibonacci is 1, and we have f should be equal to f of 2 times 1. And what's f of 2? What's the second Fibonacci? 1. So it did work for that one. Therefore, true for proposition 1. Then we have our step 2, if you want to call it step 2. And with step 2, we're going to say if P of k is such that, this is just your assumption step, S of k equals f of 2k, where, I don't want k though, excuse me, go back to r. S of r equal to k of 2r, where r less than or equal to k, or r is equal to 1, 2, 3, all the way up to k. What's that? It's just your formula here, S of n, S of r. Oh, f, yes. Thank you. F of 2r. Thank you so much. So then we've got that. We've got that. So then we are ready for step 3. Step 3 is where we do the S of r plus 1. And that should be equal to S of r plus the next term, f of r plus 1. to keep it flowing the way we did it with the other problems, the other ones that we did, we had the k as my variable. So let's keep it that way. I would never mark it wrong on your tests. If you got it this far, I'd be so happy. K, K, K. And so then, what is S of k equal to in our assumption statement? F of 2k, and then F of k plus 1. We'll just keep with the k's here. What's that?
Does it really matter which letter you use?
Well, they want you to be consistent here, and to be consistent here is we're trying to evaluate all of these, and so I'm wondering if that should have been an R before. I think the R is more flexible, right? K is just one of the many. There's probably a misprint in that other one, but we can. Don't worry about the K and R's, but I think this is supposed to be R. I think I was right. Like that. I think that's right. Okay, then that was my S of k plus. Oh, and then this one. What was the next term? What is the next term of this going to be? F of 2n, right? That would be the next term when you add the next one. I almost made this mistake, and good thing I caught it. All right, so we're okay with this S of R, and then we're going to go the next term, F of 2k plus 1 minus 1. That's the next term. Remember, this was F of 2k minus 1. That's how we found our terms. What will the next one be? We increase this by 1. So it'll be whatever the previous sum was plus the next term. So what is F of 2k plus 2 minus 1? What is that? 2k what? There you go. And so this is going to be, just a second, R plus 1 equal S of R plus F of 2k plus 1. And so what's this S of k replaced with? F of 2k plus F of 2k plus 1. And what do? This will be F of 2k plus 2, which is F of 2 times k plus 1, which is proven. We did it. Do the next two.
I don't think it should be like that R plus 1.
You finish therefore statement. And I think you're right. We keep this K. Keep this in terms of K. The only time R comes up is in that assumption statement. Isn't that good? Good.